Okay, so today we're going to learn how do we do volume conversions with stoichiometry. So before you start writing things down, let me just ask you a question about a balloon. So everybody imagine that you have this nice, pretty, beautiful helium balloon. Are we all picturing this helium balloon in your mind? Okay, how many of you park your car outside right now? Okay, if your nice, pretty helium balloon stayed in your car overnight, what would happen to it in the morning? Good. What's the temperature right now, especially at nighttime? Cold, right? So what would happen to your balloon? It's going to shrink, okay? But then what happens if you got your balloon out of your car and you brought it inside and you put it by like the nice warm fireplace? What would happen to it? Okay, it would like pump up again. So can the volume of a gas change depending on its surrounding environment, like the temperature or pressure it's in? Good. Okay, so gases do change volume. So if we're doing science or chemistry here in Colorado, okay, is our volume of a gas going to be the same somewhere else where there's a different temperature or pressure? No, it'll change. So in science, we have to have a way to standardize that, okay? So when we talk about gases, for this unit, we're going to talk about gases at something called STP, which stands for standard pressure and temperature. Okay. Bless you. Bless you. Bless you. Okay, so when we talk about standard temperature, that's equal to 0 degrees Celsius. And then standard pressure is equal to 1 atmosphere. 0 degrees Celsius, that's the freezing point of, water. 1 atmosphere is just like normal air pressure at sea level. So have any of you ever vacationed anywhere at sea level? Like Florida? Okay, so just like the normal air pressure, that's what 1 atmosphere feels like. Okay. So when we talk about STP, it's just their way of standardizing it. So if we have a volume of gas here, it would be the same volume of gas in another place. And so it turns out when conditions are at STP, 1 mole of gas is equal to 22.4 liters. Okay. Another word for that number, it's called molar volume. Okay. So that's the volume of 1 mole of gas. And that is any type of gas. So that could be water vapor. It could be carbon dioxide gas. It could be oxygen gas. It could be nitrogen gas. Okay. Any kind of gas takes up 22.4 liters. So today we're going to learn how to do stoichiometry calculations with volume. Our generic game plan, it should look familiar, but let's say we start in grams. We're still going to go from grams to moles, but now we'll just end in liters. Okay, so for our first calculation, we're going to do a mass to volume calculation. So go ahead and copy down this balanced equation up here. And we're going to figure out how many liters of nitrogen dioxide are produced if you react 22.5 grams of nitrogen monoxide at STP. Okay, so we're going to start this problem just like we've started the rest. So first you have to identify what's given to you in this word problem. Okay, 22.5 grams of?
Nitrogen monoxide.
Okay, of that I know. So next to like nitrogen monoxide in the equation, I'm going to write down 22.5 grams. And then we have to figure out, well, what are we trying to solve? So what are you looking for? Okay, so what is this problem asking you to solve for? Liters of? Okay, NO2. So I'm going to put that little question mark above the NO2, and then I'm going to put an L there for liters. So now we'll make our game plan. What unit are you going to start with? Okay, grams. You always have to start with the unit that you have the number with. Okay, and it's grams of NO. And then what unit do you have to be in to be able to go from NO to NO2?
Moles.
Okay, you got to be in moles. So then we have to convert that to moles of NO. Then what can you convert to?
Moles of NO2.
Then we can get to moles of NO2. And finally, what unit does your answer need to be in?
Liters.
Good. And then we'll go to liters of NO2. Okay, so now we can do the dimensional analysis part. So what number goes in that very first box?
22.5.
Okay, 22.5 grams of NO. And we have to get from grams to moles. So what do you use to convert between grams and moles? Starts with an M. Good. Molar mass. Okay. Where do you find the molar mass?
Periodic.
Good. Periodic table. Nitrogen is 14.01 and oxygen is 16. So what do you get if you add those together? Okay, so there's 30.01 grams of NO for every 1 mole of NO. So grams of NO cancel. So now we're in moles of NO. How do we get from moles of NO to moles of NO2? What do you have to use? Good. Okay, that mole to mole ratio. If moles of NO are on top, what has to go on the bottom?
Moles.
Okay, moles of NO and how many?
2.
2. So there's 2 moles of NO, and you end up making 2 moles of NO2. So moles of NO cancel. Now we're in moles of NO2. And that last step is to go from moles to liters. So this is that new part. For every 1 mole of NO2 gas, how many liters will it take up? Good. Okay, so for every 1 mole of NO2, it'll take up 22.4 liters. All right, so now go ahead and type it in your calculator. Calculate it just like you would with all those previous problems. What are you getting?
16.7944.
Okay, I'm going to say 16.79. Okay. How many sig figs are in 22.5? 3. So how many should be in your answer? 3. What should you round that to? Okay, 16.8. And what's your unit? Okay, liters of NO2. Okay, we're going to do a volume to volume calculation. So this time at STP, how many liters of oxygen are needed to produce 19.8 liters of sulfur trioxide? Okay, so the same thing that we've always been doing. What number is given to you in the word problem?
19.8.
Okay, 19.8. Okay, so I'm going to write 19.8 liters under the SO3. And then what are we solving for? Good. Okay, so under oxygen, I'm just going to put that question mark. That's what we're looking for. And unit is liters. Can you all see that light blue? Okay. Okay. Okay, so now we're just going to make our plan. What unit are you going to start with? Okay, liters of SO3, always the one that the number is attached to. Okay. And then what unit do you have to convert to in order to go from SO3 to O2? What unit do you have to be in to do that? Moles. Okay. So we have to go from liters of SO3 to moles of SO3. Then what unit can you convert to? Okay, moles of oxygen. And then finally, what unit does your answer need to be in? Liters. Okay, so what number goes in that starting box?
19.8.
Perfect. So 19.8 liters of sulfur trioxide. And we have to get from liters to moles. So how many liters does 1 mole of gas take up? What's that new number we learned?
22.4.
Okay, so 22.4 liters is how much 1 mole of SO3 occupies. Okay. So now we're in moles. How do we get from moles of SO3 to moles of oxygen? What do you have to use? Okay, got to use that mole to mole ratio every single time. So how many moles of SO3 are there? 2. Okay, so there's 2 moles of SO3 for every 1 mole of oxygen. Oops. And then finally, you have to convert back to liters. For every 1 mole of oxygen, how many liters will it take up? Okay. That new number, so that 22.4 liters. Anybody have an answer? Okay, what are we getting?
How'd you get 22.4?
That is the molar volume. It's that new number that was introduced to you. 1 mole of gas always takes up 22.4 liters as long as we're at STP.
Okay.
Okay, so when you multiply and divide those, what are you getting? Okay, 9.9 sounds correct. Okay, how many sig figs are in that starting number, 19.8? Okay, so what do you have to add if you need to get this one to 3 sig figs? Just add a 0. So it's 9.9 liters of oxygen. And we're going to do one last type of calculation. This one has nothing to do with liters. We're just going to do a particle to mass calculation. So we're going to figure out how many molecules of oxygen are produced when 29.2 grams of water is decomposed according to this equation. So go ahead and copy down that equation. Okay, and then we're going to start this problem just like all the rest. So what number is given to you? $29.2 grams of water. What are you solving for? Okay, molecules of oxygen. So I'm going to put a question mark under oxygen. To abbreviate molecule, I'm just going to say MC. Okay, so now we'll make that plan. What unit do you have to start with? Okay, you got to start with the numbers, so the grams of water. And then what unit do you have to be in to go from water to oxygen? This one doesn't change ever. What unit do you have to be in? Always moles, okay? Always, always. So you have to get to moles of water. Then what unit can you convert to? Moles of oxygen. And then finally, what unit does your answer have to be in? Okay, so then we can get to molecules of oxygen. Okay, so to calculate, we'll do the dimensional analysis, just like usual. Okay, so what number do you start with?
So 29.
Okay, you're going to start with 29.2 grams of water. Okay. And you have to get to moles. So how do you get from grams to moles? Okay, molar mass. Okay, molar mass. Who has water's molar mass memorized by now? Good, 18.02. If you don't have it memorized, where could you find it? Periodic table. Okay. So there's 18.02 grams of water for every 1 mole of water. So grams have to cancel. All right, then how do we get from moles of water to moles of oxygen? What do you have to use?
Mole to mole.
Okay, mole to mole ratio. What number has to go down here?
2.
It does have to be 2. Why?
Because it's the first one. I don't know.
Okay, it has. You're right. It's 2. It's because it's water. If water's up here, water has to go down here, and it's 2 moles of water.
Oh, makes sense.
Okay, so for every 2 moles of water, how many moles of oxygen do you get? 1. If no number is written, what number is implied? A 1. All right, and then finally, we want to get to molecules. How many molecules are in 1 mole?
3.02.
So close.
Really?
It's 6.02 times 10 to the 23rd. Do you remember that number?
Oh, I thought it was 3.
Okay, so then 1 mole has to go in the bottom. So for every 1 mole of oxygen, there's 6.02 times 10 to the 23rd molecules. So go ahead and type that one in like you normally do. Are you expecting a large or a small number?
Large.
Okay, really big number. Quick. Does anybody have a number? What do you have? 4.88 times 10 to the 23rd? Do you all agree with that?